I'm Preeti, Assistant Professor from the Department of Computer Science and Engineering. So today, our discussion is on Process and Project Metrics Part 2. Moving to today's agenda, that is the software measurement, right? Now, what is this software measurement? So whenever you try to document the things, whenever you have some templates which is having a complete theory notation, that is the complete documentation notation, here we have to know the need of how do you calculate the features that are involved in the process or a project. So it is like you are trying to know how complex it is. What is the reliability of the project? Is it giving us optimal solutions? In what ways are you calculating all these terminologies that we come across in the software process or in the execution of any project? So to study all those things or to know how do you manage the things in a mathematical manner or trying to record some readings for the efficiency, the reliability, the optimization, all these things we require to understand software metrics, right? So this software metrics is including few major metrics that involves. The first one is the size-oriented metrics. The second category is the function-oriented metrics. Next, reconciling LOC and FP metrics. LOC stands for lines of code and FP stands for functional point metrics. And the fourth category is the object-oriented metrics that uses various object-oriented techniques. And the fifth one is the use case-oriented metrics that involves various representations that are belonging to people, right? And what are their actions? How are they starting off their actions? How are they communicating with the system? All these things are involved in the use case oriented metrics. And the last one is the web application metrics that involves the web related architecture. It can be a single tier architecture, a multi-tier architecture that involves the communication between the user and the server. Or in the other terms, it is the client-server communication that happens between the client, which is acting as a user or a system, and the other end, the server. The server can be any kind of database that is trying to retrieve the data requested by the user on the other hand. So the operations that performs are the request and the response that is given. That is, request is given by the user and the response is generated by the system on the other end, that is in terms of server. And the acknowledgement is also generated between the to and fro process. That is, the request asked and the response given. So once the response is given, the user or the system intimates that, yes, I have got my asked data. So moving to look into what exactly measurements are. So measurements in physical terms or in the physical world are discussed in two manners. That is the direct measures and the indirect measures, right? Starting off with the direct measures, they are nothing but you are trying to find out the length of something, trying to know what exactly is the measure. When you say indirect measure, that is, you cannot measure it directly with some values or something. So the things that are involved where you cannot specify the values directly are called indirect measures. That is, what is the quality of it? Is it giving us relevant result? All these features will come under the indirect measures, right? And the last point that is stating is indirect measures of the product will include functionality, quality, complexity. That is, in simple terms, whatever are the things that you cannot measure at the first go. That is, if you see how many items are there, you can count and see the result, right? But if you talk about the indirect things that you cannot measure, so you are trying to have upon them the size-oriented matrix. That is, try to focus or implement the size-oriented matrix that is involving various functional features and other related features. So I repeat, indirect measures includes functionality, right? They cannot be measured directly, or quality, which cannot be measured directly, where different metrics have to be applied so that you can say, yeah, this product is giving us a very good output. And how do you say it is giving us a good output or a good quality? that again you have to measure it. In what ways do we measure this? We need to study the different metrics involved, right? In the same way, you cannot measure, or in the indirect measures include functionality, quality, complexity. Complexity of a project can also not be measured directly. You have to use some different metrics involved. And you have efficiency, reliability, maintainability, all which cannot be done at the first go. So all these mentioned things will be considered as indirect metrics or indirect measures. So moving to how do you focus or how do you calculate the things is the continuation of the size-oriented matrix. So when we say size metrics, or when you are trying to say you're trying to calculate size of a program, right? When you say size of a program, it is allowing us to calculate the estimation effort, or in the other terms, you can say size of a program allows us to do few things. Those few things are estimation effort, right? How are you calculating the effort of something that is being executed? That is, how are you estimating its effort? And the second category is the time scale. How are you managing the time? In what time is it being delivered? Or is it executed in this specified time slot? All those different notions come under time scale. And the third category is the total faults that are involved in the process. Total faults that are involved in the process. Meaning what? It is like the size of a process also allows you to calculate where are the faults, how many are the faults that are occurred in the entire process. Next, coming to the main critical area that is involved in the project planning is it is very difficult to know the size of the project, right? If a person who doesn't know, if we just give him a program or a code and ask him what is the size of the program or a project, he will not be able to know. So to elaborate that in a more better way, we need to study the lines of code and the functional count. I repeat, we need to calculate the lines of code or the function count. In short, it is termed as LOC or FC. These are the various methods involved to estimate the size of a program or a project. Right? Moving further, let us see what exactly is the lines of code. Lines of code, in short, it is termed as LOC, and this includes all the lines that are written in the code, the program code, eliminating the spaces and the comment lines. Comment lines are nothing but to make the program user-friendly or properly understood for the people who are referring to the code, you write some comment lines, right? Which is not considered as an actual code. So the compiler or the interpreter eliminates the comment lines and executes the code. So I repeat, when you are trying to calculate the lines of code for a program, we are not supposed to include the spaces and the comment lines, right? So that's a point that is there in the note which states, except comments, blank spaces, rest all are considered as the LOC, that is the lines of code. So counting the lines of code will tell us this is the size of your program, or this is the quantity of your program. Next, when we discuss about the pros and cons or the advantages and disadvantages of this line of code, the first advantage is it is helping us to find out the size of your program. That is a very, very important advantage, right? Now, what will happen if it is trying to tell you that this is the size of your program, right? It helps the developer to either reduce or remove some unnecessary things which are not there in which are not required in the code, so that it reduces your program and the execution time also is reduced, right? So this is an advantage in trying to know the lines of code or trying to know the size of your program. Next advantage is it is easy to count and calculate the developed code, right? Once you are aware of these number, included in the actual code, it helps you to calculate the entire developed code. At the same go, as we know, there are two faces of a coin. If there are advantages, obviously there will be an advantage for a system, even though it is a very, very good product, right? Now, moving at the disadvantages or cons of size estimation or size-oriented metrics, or trying to know the LOC of the size estimation, we can say that LOC is language independent, or LOC is a language and technology dependent, right? And the second one is if we use the software design which is not up to the mark, meaning if the coding is not properly done by the developer, there are flaws that occur which causes excessive lines of code, where it is like a direct relation. If you have excessive lines of code, then what happens? Your execution time also increases. So it is better we reduce the code to the max level, right? So moving to a small program that is here, which is talking about the greatest of the three numbers. Here it is the C program that is being depicted, where in the starting line, which is including hash, is talking about the header files and then the main function, and opening the main block of the code, you are writing different statements. Up till the end, you close it with a flower braces, right? Now, how do you calculate the lines of code for this particular program? So what is happening here is you are supposed to include, according to the definition, you are supposed to include all the lines of code, just removing the white spaces and the comment lines. So what are the comment lines here? If you can look, the first comment line that is saying, ask the user to input any three integers, right? So this comment line is to tell that to make the program more effective or more readable. So you ignore that first line, and the next comment line you have another one that is stating store input values in variables for comparison. This is again making the program readable. So eliminating the white spaces and removing the comment lines, it calculates the total number of lines of code. So if you totally count, it is around 16, and removing those two comment lines, that is minus 2, 16 minus 2, our LOC is 14 in number. Right. Now moving to the next category, as I have mentioned, FC. FC is nothing but functional count. That is also called as functional point analysis, which in short it is called as FPA. Right? Now, what exactly this helps us to do? This is trying to act as a solution to measure the size of a program. I repeat, FC is a major part which is trying to help us to calculate the size of a program. And it is also knowing the count of the functions, or having a count on functions. Right? Moving to some special features that FC takes, that is functional count or functional point analysis, FPA includes. Special features of FC include, first one is language independent, right? It is language independent. That is, independently the programs can be executed on their own system. You don't have to compare it with something, or it does not need the assistance of some other system or some other coding. The second special feature is it is trying to estimate development effort in early phases, right? FC allows us to do some kind of calculations at the early stages of the when we start processing. And the third special feature is it is linked up with the requirements. It is linked up with the requirements. And the final special feature is based on the user's external view of the system. That is how the end user is trying to view your system in terms of the functional count. These are the 4 special features that are being attained by using functional count. Right. Now, let's move to some basic principles of FPA, that is functional point analysis, right? So to elaborate these principles, we have to discuss about some functional units. So what are these functional units? The first one is the input, second one is the output, third one is the inquiry, The fourth one are the internal files and the internal logical files, and the fifth one are external logical files. So these are the 5 major functional units that help us to understand FPA, that is functional point analysis. Right now, what is input? As all of us know, when a person is trying to type something on the keyboard, you are trying to enter the data to the system. You're giving some information to the system. That's nothing but input. Coming to output, you are trying to retrieve something from the web or some kind of servers, right? Some query asked is an input. The query is actually searched in the web engines, and the server is trying to answer your question and giving us an output where the person is trying to view it is considered as output. So in other terms, input is like data entering to the system. Output is nothing but data being removed from the system or trying to be accessed by the users. Enquiries. When you say enquiries, this goes both with both the terms, that is input and output. That is enquiry input, enquiry output. This actually is trying to request an instance to access a data. I repeat, enquiries is a request for an instance to access a data. Coming to the fourth category, that is internal logical files. The name itself is saying it is internal. What is this internal? Information is within the system, or information is there in the system. Coming to the last category, that is the external logical files. External logical files is used, or it is being analyzed externally, that is by the other systems, right? So these are the 5 basic functional units for FPA, functional point analysis. Moving further, this in turn, as I told you, there are 5 functional units, that is input, output, enquiries, internal files or internal logical files. Fifth one is external logical files. All these things are acting as a functional units for functional point analysis. Now, when you consider these functional units, they are again segregated into 2 terminologies. That is transactional functional type and data functional type. So when you say transactional functional type, that is you are trying to apply some kind of transaction, right? So if you consider an example, you are trying to you're crediting, debiting, different types of actions that are being performed are called transactions, tasks. So when you say transactional functional type, it includes input, output, and enquiry. That is external input, external output, external enquiry. In short, they are as EI, EO, and EQ. Coming to the second category of functional unit, they are data functional types. The first one is ILF, that is internal logical files. Second one is EIF, which stands for external interface files. So when you say internal logical files, they are the files that are prevailing within the system or existing within the system. Coming to the second category, that is EIF, that is external interface files. That is, the user is trying to interact to know what is happening within the system, and he's trying to involve through the system in the external way. That is, trying to know the things. That is external interface units. Right? And so to elaborate this particular functional unit diagrammatically, we can represent it in this particular format that includes 3 major blocks. That is, initially the users, and then you have applications, and then you have the original application, which is considered as an application boundary. Right? I repeat, there are users, the way they interact with the present application, and how is the external interface file involved in trying to get the things from the other applications. So looking at the terms here, we have EI, EO, EQ that are all linked up with the user to the present application. Now, what are EI? External inputs. EO stands for external outputs, and EQ stands for external enquiry. That goes both with input and output. So you can see there is a bidirectional line that is present between the user and the application boundary, right? And EI as the name itself is saying, input. So it is just having a one flow, that is forwarded arrow within the application, and EO is the output. It is having the outward arrow, that is from the application to the user. In simple terms, it is like the request and the response that is being generated. Now, ILF stands for internal logical files that are present within an application, within that application boundary. Now, coming to the other applications involved, what is the user trying to do or trying to take from the other systems? Whether he is working on some servers, trying to get some resources from the other websites or something, or is he trying to involve some kind of hard disk, different kinds of multimedias, or the media servers, or all these things that come under the other applications. There comes the existence of EIF, that is external interface files. I repeat, you are trying to interact with the help of external interface files, that is trying to get the things from the other resources to the application boundaries. Now let us look at the indications that are shown. EIF, it is external. So from the other application, it is being linked up to the internal logical files, that is the applications that are existing. Then you have EQ, which acts as both the input and output. So there is a bidirectional flow. And EI, it's only the internal, so it is moving towards the application. EO, that is the external output, it is moving outward to the other applications. So this depicts a complete picture of how the functional units are acting upon or being executed in a real world. Right? So now let us come to the major part of how do you calculate the size of a program. Right? As I told you, we just have a document before us. We don't know how this program is working good. Why not the other XYZ program? ABC, let us assume that you have two programs, ABC and XYZ. How do you say that ABC is much better working than the XYZ? It is basing upon the lines of code and the functional count upon those programs. Makes it more best. Right? Now to know those things, firstly, we have to know how do you calculate the FPA, that is the functional point analysis. Right? Looking in the slide, the first thing that we need to do is to calculate the unadjusted functional points. I repeat, you have two terms over there, UFP and AFP. Right? UFP stands for unadjusted functional points and AFP stands for adjusted functional points. So there is a formula that is being shown there, which is if you are trying to give a product of the unadjusted functional points and the CAF, that is the complexity adjustment factor, that will give us the adjusted functional point. So to know all this, we need to know the procedure of how do you calculate by assuming some values which are predefined or they can be defined by the user. Okay. So to calculate FPA, firstly you need to calculate the unadjusted functional points. Then you are supposed to calculate adjusted functional points. And then you also have to know the value of CAF, that stands for complexity adjustment factor. So looking at a table that is being taken, the values in this table can be changed according to the problem or program or any kind of thing. So it is just an assumption of taking the functional units and their weighing factors. Their weighing factors are broadly categorized into low level, average and the high level. And when you talk about the functional units, as we have already discussed, they are EI, that stands for external input, EO, that stands for external output, and EQ, that stands for external enquiry. And you have ILF, that is nothing but internal logical files, and at the end you have EIF, that is external interface files. So all these functional units, we have seen a diagrammatic view of how it exists in a real world applications. Right? Now, I have specified some values. Relating to all these 5 functional units. That is, E of I or external input is having a value of 4. When you say E of I is 4, it is termed to be at a lower level. Its weighting factor is low. And when you say 5, it's at an average level. And if it's at 6, it is high. So these low, high and low, average and high are considered to be the weighting factors, which will help us to calculate the size of your program. So moving to the second one, EO, that is external output, is having a value of 7. And then it is having a value of 8 for average, having a value of 9 for high. Same way goes with EQ, 4 for low, 5 for average, 7 for high. Then ILF, that is internal logical files, is taking a value of 8 for low, value of 10 for average, value of 15 for high. And then you have the last one, external interface file, which is having 6 low, 8 average, 10 as high. So moving forward to see the calculation of it, suppose, right, as I told you, these are the parameters that can be specified by the user. It is like it is not predefined. I just have to take 10 of low complexity, 12 of high complexity. It is not like that. It is basing upon the assumptions or the things that can be done by a developing team. So here I have just supposed E1 to be 10 of the low complexity, EO to be 12 of high complexity, right? And EQ to be 6 of average complexity, ILF to be 3 of average complexity, and EF to be 8 of low complexity. Now, once these have been given, how do we calculate their values? So, as I told you, 10 of low complexity. So, when I say 10 of low complexity, it is nothing but, what is the value of low? It is 4, right? So, 10 cross 4 is 40 is the value for EI, that is external input. So, taking E naught, that is 12 of high complexity. Now, go to the field of E external output and check for high complexity. EO high complexity is 9. So, what do? 12 of 9 is 108. Next, the same way you calculate for inquiry as well, 6 of average. So, what is 6 of average in EQ? It is the value 5. So, I write 6 cross 5, which is 30. Then I have ILF, which is 3 of average complexity. That is 3 of, what is the average complexity of ILF? It is the 10. So, 3 of 10 is 30. And the last one, that is EIF, that is external interface file, is 8 of low. So, what is 8 of low in the last field? It is the 6. So, you have 8 into 5 is 40, yeah. Right? You calculate the relevant features. Then what do we do? Whatever you have, while values that are obtained on the top are summed up together, it is giving us UFP. UFP stands for unadjusted factor. Okay. Now, as I told you, to calculate CAF, that is the complexity, it is derived from the formula that is there, 0.65 plus 0.01 cross the summation. Right? Now, here comes the question of what is that Fi, right? So, our formula is CAF, which is 0.05 plus 0.65 plus 0.01 into summation of Fi. That Fi is nothing but the total complexity adjusted value. Now, our question is, how do I calculate the Fi? How do I calculate my Fi? This Fi are the factors that again have to be assumed by the developer, who draws them on a scale of various features, indicating them the low to be the 0 and the topmost, that is very effective, to be the 5 on a scale. Basing upon all those factors, we are calculating the Fi. So I repeat, Fi is the degree of influence and one based on responses to the standard questions, right? So this is nothing but the total complexity adjustment value, right? Now let us look at this particular slide, which is trying to tell us how are you trying to get the factors. Firstly, you have to monitor them on a scale of 0 to 5, where I am indicating 0 to be having no influence at all and 5 to be having essential. 5 is the essential. right? We all of us know, try to rate yourself on a scale of 1 to 10, and there are some fields that are given from 1 to 10. Basing upon your work given or work assigned to you, you place yourself on below 5 or above 5, right? On the same way, if we have to know the FI, right, you are supposed to talk about these rating of factors on this particular scale, where 0 is no influence, 1 is incidental, 2 is moderate, 3 is average, 4 is significant, and 5 is essential, right? Now, coming to the factors that are considered. Now, let me tell you, the 5 factors that are present before you are just the major factors given by an individual. Now, these factors, let me tell you, can be 5, can be 10, can be 15. It depends on the project that you are working on, right? So, when you are considering this factors, they are nothing but FI. Your first questionnaire is, do the system require reliable backup requiring, right? For that, if for this question, my answer is average, I am saying, right? So when you say average, where is your average lying? It is lying on the scale of 3. So my FI value becomes 3. Same thing if I move to another questionnaire which says, is data communication required? So I feel that yes, moderately, I feel that yes, data communication is required. There I am giving it as F2. F2 is nothing but the moderate on my scale of 5, which is the 2. So my value of FI or F2 becomes 2. My third questionnaire, distributing processing. Is your project requires processing it in a distributed manner? Then you have set 3, which is nothing but average again. So my value becomes whatever is there on the scale. Next, I write performance critical area. F4 is nothing but 5. And like that, I also state my online data entry. Yes, I require 3, I have said. So I try to sum up all these values. I sum up and make it a summation 5, right? So what is the formula? To calculate the complexity, it is nothing but 0.65 plus 0.01 into summation of Fi. So here we have got our summation, that is the 15. You substitute in the relevant formula for complexity, which is 0.65 plus 0.01 into summation of Fi, which is nothing but 15. And this ultimately results in what? The 0.8 value for CAF. That is the complexity value you have obtained to be 0.8. Now finally, we are trying to calculate the adjusted factor, right? That is AFP. So AFP is nothing but UFP, product of the complexity. So I repeat, to calculate the adjustment factor, you need unadjusted factor, product, the complexity. So priorly we have calculated the UFP from the values where it has given us 253, product 0.8. So our total adjustment factor is the 202.4. So basing upon this, you can say how effective is your program, right? The same calculations can be done for another program, some XYZ program, where your AFP is more or less. So basing upon the values that have been obtained, we say that how best is your program, how efficient is your program, can it be included as an integral part in the entire development process of your project, right? So moving to the next one, that is the object-oriented metrics. That is the next category in the size measurement. Now, what is this object-oriented metrics? So, as I have told you, we have discussed LOC or FP, which are considered to be the conventional software project metrics. That is, they are a kind of conventional measures that involves LOC and FP, the lines of code and the functional points, right? And they can also be used to estimate object-oriented software projects. So, what is it trying to tell you? So these projects do not provide granularity for the schedule and effort adjustments needed in an evolutionary or incremental process. So what it means to say is, this lines of code and the functional points, what have been stated, they cannot provide the granularity for the schedule, for which a set of other metrics that are involved in the object-oriented projects have been designed or developed. Out of that, the first one is the first key factor of object-oriented metrics is number of scenario scripts, right? Now, when you talk about the scenario script, it is trying to tell us about the detailed sequence of steps that are involved. I repeat, detailed sequence of steps that are involved to show the interaction between the user and the application. That's the first step that is involved under the scenario script. That in turn is under the object-oriented metrics, right? Now, there is a form of a small code, or you can say any script or each script that you are trying to divide it into modules can be understood or organized in the format that is given, that is initiator, action, and the participant. Initiator, actor, and the participant. So what is the initiator trying to do? What is this particular initiator trying to do? They are trying to request some service, right? Requesting some services, as I told you, you are trying to request or pose a question to the browsers. That is to the trying to get the information from the servers, right? Next, what kind of action that is being performed, right? It can be by user or any other participant who's trying to satisfy the request of the server. And participant, yeah? So these are the three main things that are there to elaborate what an object-oriented metrics is trying to talk about. That is the initiator, action, and the participant, right? So moving to the second category under the object-oriented metrics is the key classes. Now, what are these key classes? They are trying to act as highly independent components, right? This is very, very important. That is highly independent components. So when you say there are some components which are having their own features, they are termed as key classes, right? Now, what is their main focus is about? Whenever you are trying to discuss any problem, it can be related to any domain. The central part of whatever you are focusing are nothing but the key classes, right? And you also they also help us to focus on the effort required to develop that particular software, right? And finally, you can also say whatever has been stated, there is also an option for reusing, right? So I repeat, key classes are highly independent. They are the major factors for a problem domain. They discuss about the effort that is required involved in a software, and they are also reusable, right? Next, the third category under the object-oriented are the support classes, right? Previously, we have seen key classes which are independent, and here you have something called support classes, right? Now, what are these support classes trying to focus on? Right? They are trying to be used or implemented, are required to implement the system, but are not immediately related to the problem domain, right? So if you can look at the first point, there is a difference between the key classes and the support classes. Key classes are independent classes, right? They completely focus or give us a rough figure of what exactly is the problem domain trying to focus on. But when you say support classes, they might not be directly related. Okay? Some kind of examples are the GUI, that is the graphical user interfaces, right? And they are iterating throughout the entire process. They are defined to be iterated, or they are involved in iteration throughout the process of execution. And one more thing is, the support classes are trying to indicate something, right? They are trying to indicate the effort that is required. They are trying to indicate the effort that is required. And also, reuse is also applied. Potential amount of reuse is also an indicator factor in the support classes, right? Moving to average number of support classes per the key classes. We have seen what are key classes. We have also seen what are support classes. Key classes have a complete focus of what the problem domain is. Support classes may not be aware of what exactly the problem domain is. So what is the average number of support classes per key class? Meaning for one key class, as it is an independent feature, how many support classes are required on an average? So it's defined in this category again throughout the process of your execution. So for this, the person named Lawrence and Kidd has suggested, right? What has he suggested? That applications with GUI between 2 or 3 times the number of support classes as the key classes. So in short, he is like, on an average, you can have 2 to 3 support classes for a single key class. Moving to the 5th category, that is the number of subsystems. As we all know, what is a subsystem? The name itself is saying sub, meaning it is below a original system, right? So a subsystem is an aggregation of classes which are trying to support a function that is being visible to the end user. So I repeat, subclasses are aggregation to the classes that are existing and they give us a complete picture. That is, the end user picture will be given. Okay. Once you are trying to identify, once the subsystems are identified, what you can do? You can schedule for a reasonable schedule can be sorted out, right? And to make them more effective, we are using this kind of object-oriented environment that is being shown here. So in terms of various measures like the errors, defects that can be uncovered and various modules and documentations. So I repeat, the 5th category of the object-oriented metrics are the subsystems. Subsystems are acting as an aggregation of the classes, right? Once your subsystem is identified, they are completely trying to focus on the schedule and effectively focus by using various techniques for object-oriented environment, where they have the focus on the efforts, the errors, the defects, and the documentation portion and all these things. And there is also something called when the database is trying to grow, that is, when there are different relationships, there also this particular subsystem acts as a major feature, right? The next category of the size measurement are the use case oriented metrics, right? When we see use cases, it is like, it is trying to, use case can be pertained to some procedure or a user or a system on a whole. What are his features when he is relating to another system? There we talk about the use case oriented metrics, which is again lines of code and functional point metrics can be used for estimating object-oriented software. So what is the first point saying? We have discussed the lines of code and we have also discussed the functional points, right? So these lines of code and functional points were trying to estimate the OO software projects, that is the object-oriented software projects, right? So sometimes these also were not up to the mark, right? They were not able to satisfy the things a developer needs. There, in case, we have come to use this use case oriented. So, which is focusing again on the scenario scripts. As I told you previously, scenario scripts involve a sequence of steps that is trying to interact between the user and the application. Here, you try to develop various kinds of test cases and trying to focus upon their application size and the number of test cases that are there, right? So this is the first category, that is using the scenario scripts under the use case oriented metrics. The second one again are the key classes for the use case here, and then you have the support classes as were depicted before. So as I told you, key classes are acting as an independent components, right? Where the problem domain is notified, and you can also have the reuse feature. When you say support classes, you may not have, they're just acting as a support class. You may not have a complete idea about what exactly is the problem, right? So here it focuses more upon the user interface classes and computation class, which are called the support classes. When I said user interface classes, they are nothing but the GUIs, right? GUI example, the best example is the ATM screen or the games that you play. They're acting as an interface, right? You don't know what exactly the code is behind it, right? But you are trying to interact with the system. So that acts as a GUI, right? So moving further, you also have average number of classes. That is, in the use case also, you are trying to specify how many support classes are required for the one key class, right? It helps you to estimate a proper average. Fine. The next category again is the subsystems. The subsystems, which is called the aggregation of the main system, and it is trying to identify preparation for a reasonable schedule. That is, once you have defined some subsystems, you can focus upon the schedule on it and you can interact with the subsystem, and it is again divided into various project members within a team. So I repeat, the number of subsystems, subsystem is nothing but the aggregation of various classes, and those are again having their own individual tasks where they concentrate on their own schedule that is being defined. And the next category in the size measurements are the web application project. So the name itself is saying web application. How are you developing an application for which you require various web pages, and those web pages have to be merged together. They have to be linked up together, right? So you can see the objective of all the web projects is to deliver combination of the content and the functionality to the end user, right? It's nothing but just take an app. You just go to Play Store, you open some apps. Each apps that you open is a web application, right? So web application is comprising of various web pages, meaning when you have opened to book some food item, right, in Swiggy. So Swiggy, there is an app. When you are trying to open that app, the first thing shows you the different menu items which are there. You try to select. It takes you to another page. So trying to merge all these things, right, and making it a final web application. So what is it trying to tell you? It is trying to combine various content and trying to give a final functionality to the end user, right? And next, here again, we are supposed to discuss about the static web pages and the dynamic web pages. So what do you mean by static web pages? Web pages are static content. So when do you say web pages are static content? That is, the end user has no control over the content displayed on the web page, right? Whenever the end user is not able to modify the content or the content displayed on a web page, so that particular web page is called a static web pages. So when he is not having access to modify the things, obviously you term it to be the low relative complexity, and generally it is having less importance when you compare to the dynamic web pages, right? So moving further, let us see what are dynamic web pages. This dynamic web pages is allowing the end users to perform some kind of actions. They can be external and they can also result in a customized content, right? What do you mean by the customized content? They can be some e-commerce application. The best example for e-commerce applications is the online shopping, where everybody is doing, right? You are doing online shopping for each and everything, right? You're not going out. Let it be. Initially, we used to go out for buying various things, but no, you are actually getting your from where your day starts. You can also book the milk packets online. He delivers it to you. Then you want your breakfast, it can be done. Then you want to go to your office place, you book a cab, right? Coming to the office place, you do your duty again, then you go back, you have a cab. Like that, you can do a lot of things. That is, e-commerce applications involve the dynamic web pages, and you have various search engines, right, trying to search the contents, and various financial applications or financial applications, the banking domains. All these are nothing but the dynamic web pages. They are completely complex when you compare them to the static web pages, right? And you all have one other category, that is the internal page link. As I told you, whenever you're creating a web application, you are having various web pages involved to it. Right. We all know what are the hyperlinks. When you are creating a web page, when you just click on the menu that you have selected, if you're trying to buy a food item, so some out of 10 you have selected some 2 to 3. When you click on it, it may go show you the options of how you buy it with the help of cash, card, or any other source. It is like trying to link up. So all these things are how many internal page links that are being provided. So this is nothing but pointers that provide hyperlink to some other web pages, right? This is internally to move from one web page to another. Internally, there is an architecture diagram that is representing an architectural figure, which is degree of architectural coupling within a web app, right? So as the web pages are increasing, your construction cost or your construction work is also increasing, right? It goes on. So static, there is a lot of work to do. Next is the number of persistent data objects. Number of persistent data object is nothing but the file management system, the database management system, where you are trying to include more data objects into it. So more data objects that are being increased, the more web application keeps on growing. Right? So moving to another two sections of the web application project metrics are the number of external system interfaced, right? How many systems are being interfaced or merged or viewed externally? That is, in the other terms, you can say interface with the backroom business applications. That again is done with the help of web app project metrics. That is, you're trying to internally merge the things. Backroom, that is, various business applications also can be merged. So I can tell you a simple example, right? If I'm trying to start one of my business, right? My own business I want to start off. So I will have to do the publicity. So there are different ways for me to do the publicity, right? Whenever, if you have observed, if you are opening your email ID or if you're trying to if you're trying to search some content, right? There are some ads that are being projected right side, right? Which says it can be an online shopping. So if a person who's trying to work gets attracted to those ads, then you go click on it. Then it is trying to show you the process of what you want to buy. So these are another examples of how do you trying to merge various business applications together, where the development also increases for that. And the number of static content object, as I told you, it is of a lower complexity, right? And it also includes various text-based, graphical, video content. Whenever you say static, it is like static content objects that are involving various graphical videos, animations that can be merged up. And you can say multiple content objects may appear on a single web page as well. So all these things that involves various static content, dynamic content, and the executable functions as well. That is nothing but trying to show completely or trying to give the end user his end product with the help of executable functions. Executable functions is nothing but what are the service, how are you computing the things, how are you trying to do it, whether you are using a script or whether you are using an applet, or what are the different ways in the programming or coding that you are using. They are actually called as executable functions, right? And there is a small thing that says each of the preceding measures, whatever you want to do in a web app, right? You can measure the things at the early stages itself, right? You can do it by knowing the static web pages, by knowing the dynamic web pages, and then you can customize them with the help of the expression that is C equal to NDP by NDP plus NSP. NDP stands for the NDP stands for the dynamic and NSP stands for the static web pages. So with the help of this, you can able to accomplish whatever has been defined. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.